All right, in this video, I'm working on how to graph the solution set to a system of linear inequalities. All that means is you're going to have two linear inequalities on the same coordinate plane. Okay. All right, so let me go ahead and do number 9. So what I'm going to do is use the process we just did in the previous video to graph each individual inequality. And then the answer to the question is going to be where the two overlap. It's the intersection over the overlapped area of the shaded regions of the two. Okay. So first I want to graph the line negative 3x plus y equals negative 5. So I'm going to either solve for y, so like I could add 3x, and I'm just going to use a variety of graphing techniques so that you kind of recall them. So for this one, it might work well just to get the y by itself, so we can use that idea of slope and b. The slope is 3 over 1, so that's a rise of 3, up 3, right 1. So up 3, right 1. So we're going to begin this to graph this one. I'm going to begin at negative 5. Hold on a minute. I moved something here and I need to get out of it. Okay, so I'm going to begin at negative 5, and then I need to go up 3 to the right 1, up 3 to the right 1. I'd like to do it a couple times because I'm going to graph my line in a minute. When I'm looking at that first one, do you see how it's strictly less than? So it's going to be dashed when I do it. Okay, so it's going to be, that's line 1. I'm going to label it with a 1, and it's dashed. All right, now I need to test to decide which side to shade. I think I'll use this 0.00 to test. Okay, so when I plug a 0 in to the inequality, let me do that. I'm trying to decide how to organize this. Let me just plug it in right here. Take 0, plug it in, negative 3 times 0 plus 0 less than negative 5, and that's a question mark. Is that the case? Is 0 less than negative 5? No, it isn't. 0 is not less than negative 5. Now, you could do a nice shading of the side, the appropriate side. It gets kind of messy when I do that, so I'm going to do little arrows. So 0 didn't work. It didn't make it true. So I should shade this side of that line. So I'm just making little arrows to remember that's the side I'm going to shade. Okay. Now I'm going to graph the other line. So I'm going to do question number 2 now. So I'm going to wind up graphing x plus 2y equals 4. I might do that one using intercepts. If I put a 0 in for y, that would knock out the 2y, and I can see that x would have to be 4. If I put a 0 where x is, then I'd have 2y equals 4, so y would have to be 2. So here's 4, 0. 0, 2 would be here. And this one has the or equal to on it. So when I connect those, it's going to be solid. Okay. All right, then I need to find a point that's not on the line and test whether it's a solution or not. So I think I could use that same point as my test point. It would work well. So now I'm going to test 0, 0 in the inequality. Is 0 plus 2 times 0 greater than 4? Is 0 bigger than 4? 0 bigger than 4? No. So here's 0, 0, and it doesn't work relative to the red line either. So I'm going to shade away from that point, shade the side that does not include it. See how that makes sense? 0, 0 is not a solution. Okay. Now I'm going to look, and I'm going to do my answer in purple. Change that to a purple. And let me make it a pen. Oh, well, it's okay. All right, so I'm going to do it in purple. And I'm looking for where the arrows point into the same region. So remember how you have like 4 regions here. There's 4 spots. I'm looking for where the arrows point into the same region. And I see that right here. Okay, right there. So the points in there would work in both inequalities. The points on the red line would work in both because it's solid. The points on the blue would not work, and that point of intersection would not work. But this would be the solution right here. The solution set would be all the points in that purple region. Okay? All right, let me try number 10. Okay, so the first equation is 3y less than or equal to 4x. So first thing I'm going to do is graph that equation, 3y equals 4x. Y is almost by itself, so I'm just going to go ahead and divide by 3. So I have an equation where the slope is 4/3. And notice there's no number after that, so it's like plus 0. The b value is 0. So I could begin at 0 and then move up 4 to the right 3. Okay. Now this one has an or equal to on it. So does the bottom one. Both of those are going to be solid when I go to graph them. So let me make a solid line. And if I went up 4, right 3, or if I went down 4, left 3, I'd have a slope of positive 4/3. So sometimes I'll do that one so I can get my line. There it is. Okay. Now the second part of it is to test a point, and I can't use 0, 0 because it would be on the line itself. So I might go over and use something like 2, 1. But again, notice how I have that denominator of 3. I think what I'll test is 3, 1 because putting in a 3 works better. Let me get rid of that dot I put right there. Okay, so what I'm going to test is 3, 1. So I'm going to take and plug a 3, 1 in. I can do it in the original, or I can plug it into the one I adjusted, but I'm just going to use the original. I'm looking at 3y, whether it's less than 4x. So I'm going to put in a 1 for the y and a 3 for the x, and I'm looking for whether that's true or not. Is 3 less than 12? Yes, it is. This works. That means I need to shade towards that point, the side where that point is located. Okay. All right, now I'm going to graph the second one in red. All right, so the second equation, I'll do it down here. The second equation I'm graphing is y equals 3x minus 5, which is already in slope-intercept form. I like the slope to be a fraction, so I can always put a 1 underneath it. And you have to begin with your b value. So I'm going to begin at -5 and go up 3 to the right 1, since it's a positive slope. Up 3 to the right 1. Up 3 to the right 1. Okay. And that one's also has the or equal to, so it's solid as well. Okay. So there's the red line graphed. And then I need to test a point. So I could use 3, 1 again. It doesn't have to be the same as what I used before. I could use anything I wanted, but I could test the point 3, 1 again. It's not on the line. So if I put a 1, and I'm going to the inequality, I'm testing y greater than 3x minus 5. Okay, so let me put a 1 in for the y. Let me put a 3 in for the x and see if that's true. Is 1 bigger than 9 minus 5? Is 1 bigger than 4? It is not. So relative to the red line, 3, 1 is not a solution. So I need to shade away from that 3, 1. I need to go the other way with 3, 1. Okay. So this one's got, 4 regions like the other did. 1, 2, 3, 4. Think of this as the pivot point right here, this point of intersection. And you're trying to see where the arrows point into the same region. Okay. So what I'm noticing is let me see how I can tell you without doing it. If I'm in this region, let me do it in black, only the blue goes into that region. Okay. When I'm over to this side, only the red goes there. Neither blue or red are here. So the solutions are actually, let me go back to my purple pen, going to be where the red and the blue both happen. That's pointing into this little region right here. And the lines are solid, so they're part of the solution. Point of intersection is part of the solution because both lines are solid. So it's that's the solution right there. Okay. All right. So all you're really doing when you have the two inequalities is you're graphing both of the inequalities on the same coordinate plane and looking for where the shading overlaps. Okay. All right, I've got two more we're going to do. So let me go back, do the first line in blue. So I love it when it's already in slope-intercept form. So I'm graphing y equals 1/2 x minus 2. That's my m, that's my b. So I'll begin at -2, and the slope is 1/2. So the rise is 1, the run is 2. Up 1 over 2. Okay. I can go down 1, left 2, and I'd still be on the line. Okay. And this one had strictly less than, so it's going to be dashed, isn't it? So let me dash the line, connecting those points. Okay, there we go. All right, I need to pick a point to test. Let me erase that little stair step now so it's not as messy as that previous problem. So I'm going to pick a point to test. You can pick anything you want, like 2, 2, whatever you want to test. So I'm going to pick, though, something that works with a denominator of 2. So I like the idea of an x value that's like a 2. All right, so here's what I'm testing. I'm going back to the inequality, and I'm going to test some point, and I wanted to pick something that had a 2 for the x, so it would work well. 2 for the y, 2 for the x, and I want to see if that's a true statement. Is 2 less than 1 minus 2? Is 2 less than -1? No. -1 is smaller. So that does not work relative to the blue line. So my solutions are going to be the points on this side of the blue line. Okay. All right, now we're going to graph the second one. Doing it in red. Okay. And when I graph the second one, I think I'll just use intercepts. What I'm graphing is x plus y equals 1. So if I put a 0 in there, y would have to be 1. If I put a 0 in for y, x would have to be 1, or I could put like a 3 in for for x, and y would have to be a -2. Okay. So when I plot that, here's 0, 1, here's 1, 0, here's 3, -2. This one's got an or equal to on it, so it's going to be solid when I connect them. So let me get that part done. Okay. And then I need to decide how to shade. I might use that 2, 2 again because it works for that line also. So now I'm going to test a point. It doesn't have to be the same, but 2, 2 was easy to use. So let me try it. If I put a 2 in for x and y into that inequality, x plus y less than 1, I would have 4. And 4 less than 1 is a no, not true. So that does not work for the red line either. So that means I have to shade away from it. You get that idea? Beginning to understand? Okay. And then there's 4 regions. You see them? Let me do those 4 regions in black so you see them. So here's a region, here's a region, here's a region, here's a region. Think of that intersection point as the pivot point. And it separates the plane into 4 regions. And you've got to show where the shading overlaps. So you're looking for where the arrows point into the same region. So do you see how I got the blue arrows pointing this way and the red arrows pointing this way? It's going to be that region at the bottom here. Okay, that's where they match up. Now, one line was solid and one was dashed, so the intersection point's not a solution. It would be an open circle, but these points over here are solid, so they would be part of the solution, and so would all of that. All right, and then one more that involves a special line. Okay, so we're going to graph this first line. So we're going to graph y equals 3, and it's solid. And y equals 3 means all the y values are 3, so you're always going to be up 3. So it's going to look like that. You don't normally need to use a test point for these. If you want your y's to be less than 3, you would clearly have to be below that line. Now you can be all the way below, like all of these points, all the way down. But I'm just doing the little mini arrows to keep it from being too messy. But it does go past the x-axis, just all the way down. All right, now I'm going to graph the other line, 2x minus y. I'm going to graph 2x minus y equals 2. It's strictly less than, so it'll be dashed. And I might just look for ordered pairs on this one. If I put a 0 in for y, I think you can do that one without really much work. If you put a 0 for y, do you see how 2x would have to be 2? 2x would have to be 2, so the x would have to be 1. You can do as much of this as you need to. It's just when you can do it without writing, it's okay. So 2x would equal 2. When you divide by 2, x would wind up equaling 1. Okay, so we know the point 1, 0 is on that line. Okay, and then you can try something else. So let me get rid of that work. All right, so what about if, well, what if I used a 0 for x? Okay, then what I'd have is 2 times 0 minus y would have to be 2. So negative y would have to be 2, which means when I divide by negative 1 to get the y by itself, the y value would have to be negative 2. So down here. Okay. Now you could have tried other stuff, like you didn't have to try the zeros if you're having trouble with those. You could do something like, what if you put a 2 in for x? That'd be 2 times 2 would be 4. I'd have to have minus 2 to get 2. So 2 would also be on that. All right, now we already talked about the fact that that's going to need to be dashed. Okay, so I'm going to dash that. And then I need to test a point on this one to decide which side I'm going to shade. So maybe I'll use the origin again and see if 0, 0 works. So I'm going to test 0, 0 in the inequality. Is 2 times 0 minus 0 less than 2? See how 0, 0 works well when things are in standard form? It zeroes out that side. Is 0 less than 2? And the answer would be yes. So 0, 0 works relative to the red line, so I need to shade the side where 0, 0 is. Okay. All right, now let me go to my black pen. So remember how this is a pivot point and you have these 4 regions. Here's some points, here's some points, here's some points, and here's some points. Okay, I need to find the region where both the blue and the red arrows are pointing. So do you see it? Okay, it's not here. Nothing's there. Only the blue are here. Up here, only the red. I need this region right in here. So shade that. There should be a tool where you kind of dump paint or you click in there and it fills in that region. Okay, so I'm going to do that. And then these points are part of the solution because that's solid. These are not because it's dashed, and so that's not either. That would be an open circle. But mainly they're interested in this. These are the solutions, the points that would be part of the solution. Any ordered pair in there would work. All right,